Hello everybody, and welcome to Simple Rockets 2. Today I will be demonstrating some different systems of the rocket, such as propulsion and control surfaces and the actual controller itself, that being the capsule for the humans, and different things like that. I'll also be demonstrating flight mechanics. I have this very simple twin engine rocket already pre-built, and I will quickly, or as quickly as I can, run down all the systems of the rocket, such as controls, thrust, and some of the more finer details of the rocket. Okay, so first part that I want to touch base on is the capsule. I mentioned it earlier, but I want to go in more in depth. So this particular capsule actually has, or command pod actually has, humans in it, or humans with asterisks and air quotes. But this works as the command module or the command pod again, and it helps everything such as the thrusters and different subsystems if this had fins or something else on it, it helps those actually be able to function and maneuver. But the most important thing for this rocket is the gyroscope. And as you can see here, the gyroscope has a power factor, 50 out of 100. This actually keeps the entirety of the spacecraft straight up and down whilst in flight. So it keeps it from flipping over and spinning out of control and inevitably crashing and burning. It also has autopilot. So autopilot is suggesting for aircraft, which allows an aircraft to maintain speed, sometimes maintain speed and altitude, but it's usually maintaining just altitude and not speed. And it's basically telling the entire aircraft, it's basically saying, hey, stay at this altitude no matter what. There's advanced part settings like buoyancy and stability. I'm gonna stop you right there past me. Hi, it's me from the future. I just wanted to go on record and say that stability does not refer to the gyroscopic stability of an individual part. It actually refers to the connection force or the ability to connect two parts together without those parts wobbling. It refers to connection friction or connection stability. That's what stability means. The Tinker panel part scale, this just scales how large or how small the command module is. Mass scale, that is mass. So this will affect mass, which is labeled in kilograms. Heat shield, this is how much heat the actual part can take before exploding. Max temperature, that ties into heat shield, but the heat shield actually shields everything under it, so it prevents things like the fuselage from heating up just from the heat of the capsule alone. Max temperature is how much the part can take. Drag scale is how much drag is affecting the capsule, and part collisions. That's just game stuff, and that's pretty much it for the command module. So the command module is very important for the rocket. you can almost never fly without the command module. Next part is the fuselage. So I'm going to be looking at this fuselage, and this fuselage has hydrolox, which is hydrogen oxygen, or hydrolox for short. There are different types of fuel, hydrolox being one of them, methalox, methane, oxygen, liquid hydrogen, water, monopropellant, which is used by RCS. RCS is used for tilting, rolling, pitching a spacecraft or a small module of a spacecraft in space, because in space you can't use ailerons because there's no air. Solid, which solid fuel type is can range from anywhere from wax to gunpowder. So it by solid, it's just giving a broad overarching definition of what a solid fuel is. Xenon, which is an inert gas used by ion engines. Battery, it's used by gyroscopes, so the command module actually uses power, and so having a battery on board is actually helpful. Jet fuel, there are jet engines. As I mentioned earlier, you can build planes. This program is not just strictly a rocket launching program, it is also planes. And Kerlox, which is kerosene oxygen, liquid oxygen, and back to Hydrolox, which is liquid oxygen and liquid hydrogen. And I really quickly want to correct myself. I want to say it says here liquid oxygen and liquid hydrogen, so that means that there's liquid methane as well for methalox. Liquid hydrogen is just purely liquid hydrogen, and liquid hydrogen for use in rocket engines without the oxidizer, the liquid hydrogen is even more efficient, but it can only be used in nuclear rocket engines. So there are nuclear rocket engines in the simulator. Water, that's also used in nuclear rocket engines, monopropellant, solid, xenon. Yeah, I've already touched base on this stuff. So, and then there's advanced parts, heat shield, buoyancy, tinker panel, part style. Part style just changes the style of the part. And then there's nose cone. The nose cone is basically just a tapered extension of the fuselage. And that is it for this section right here uh, of the rocket. And then here we have solid. So I'm going to detach. No, I'm not going to do that. I'm going to detach that. And as you can see here, there is a solid rocket booster here attached on the underside of this rocket. So this rocket runs off a solid type propellant or solid type fuel. And I'll touch base with all of these parts and what they mean later on. But again, as I explained earlier with the fuel types in these fuselages over here, these ones, or this one, runs off solid because based off of rocket engine, uh, the rocket engine type, since um, it's a solid rocket, meaning that it runs off either somewhere between wax or gunpowder. It can provide more thrust, but it's not as efficient. And this part right here is an interstage, so it's basically just a hollow fuselage, which is which can be used to house rocket boosters, engines, or capsules, or anything you want it to house, you name it, you can basically fit into this. It's not strictly restricted to, rocket engines. These parts right here, this part is called a side decoupler. Basically, its only purpose in life is to detach this fuselage right here once all the fuel inside of it is spent. This fuselage right here is completely empty since there is no thruster or engine in here inside the fuselage, so there's no use for having fuel. It would basically end up as dead weight. And last is the twin boosters, or the twin engines down here. And there's a lot that goes into these engines, and as I said, um, I will get into more detail with these engines and performance analyzer and different things like that. But for now, I want to quickly run down everything that the part properties of the engine has. So mass and price, 6.5 million per engine. The mass is 2,596 kilograms. Size, that is scaled in percentage. Engine type, that's what type of fuel it runs off of. As I said earlier with the solid rocket, it's just the engine type determines what the engine can do and how efficient and how much thrust it provides. Power cycle is um, it it's the method used for injecting the propellant into the combustion chamber, which it can, and that can actually really affect how the rocket performs in general. Fuel type, that also affects how much thrust the rocket boosters output. That is how much pressure and megapascals there is inside the chamber, the combustion chamber, and that affects fuel efficiency and thrust, but it adds additional cost. Gimbal range, that is how far the rocket boosters themselves can rotate in order to rotate the entire aircraft around the axis. The nozzle, that just affects this, but it also affects thrust, throat size, and nozzle length. So I'll touch base on those later. But now that I've given a rundown of the entire rocket, there's one last thing that I do want to give a quick look at, and it is staging. So, in basic terms, staging is the sequential order of how things will, and staging happens again in sequential order, so stage 1, stage 2, and stage 3. So this would be classified as a 3-stage 30,806 kilogram rocket. So first stage encompasses the 2 rocket engines down here. So that is the basic terms of staging. But that's basically how a rocket works, but that was very simplified, and as I keep mentioning, I will touch base on everything and go into deeper detail of everything later. But now, we should go and launch the rocket, and instead of me just talking and showing everything, I might as well show you how everything works. So, um, there are a few things. So this blue ring right here controls my my pitch, and this orange ring right here sets my roll, and then flight view has a few different tabs: fuel, velocity, performance, orbit, autopilot, and options. Really all I'm going to be worried about is fuel and velocity. And in velocity, all I'm going to be worried about is angular momentum, so that is how much momentum I have in degrees, and then acceleration, that is how fast I'm going in meters a second. Active stage, that just shows how many active stages I have activated, so I have no stages activated. How much monopropellant I have left. I didn't even have any monopropellant to begin with, so it makes sense that this is 0. And battery, that just refers to how much battery I have for the gyroscope powered inside the capsule. So, yeah. Surface and altitude is here. And this is throttle. The orange bar right here is throttle. So I'm at 100% throttle. And then this blue bar is my fuel. My fuel is empty because I have not engaged stage 1. So enough jibber jabber. Let's engage stage 1. My fuel is 100%. I'm going to set my heading. So this is a heading bar. So these are both heading bars. I'm going to set this. So right now it's at 90 degrees. And so now we're going to engage our engines. This green arrow is showing me my actual like orbit based off of my velocity and all that stuff. And if you can see here, this gray one is so now that this stage is out of fuel, I'm going to press space and then press space again and engage my solid rocket. And look at that. I'm already out of fuel. But now I can look at my map and look at that. So this blue line is my orbit, and this is considered, this green arrow right here is considered my apoapsis, being the farthest point away from the Earth's surface, or um, a, a celestial body being used as a point of reference. That could be the Earth, the Moon, or the Sun, or one of Saturn's moons. It's really anything that has a gravitational effect on the body that is either in orbit, or as this rocket is, you could pretty much classify this as a missile. And this point right here is determining where I'm going to smack down into the ocean. So I technically consider this as a as a successful mission. And we can look down on Earth and see the haze. We can look out at the sun, blind our eyes. That's pretty much it until the spacecraft falls back down to Earth. That is how that works. And to show my my gyroscope in action, so watch my battery, I'm going to adjust my heading. I have no thrust, no RCS, nothing. I'm just using purely gyroscope. And I'm going to set my heading to, or my pitch to 45 degrees. My gyroscope is going to turn the capsule, which is going to turn the entire spacecraft to point in the direction that I have um, set for my pitch. And then my battery is now at 96%. I'm going to affect my my heading. And this down here, that's the moon. So, and that's basically it. I mean, right now we're technically in space, but we haven't broken Earth's orbit, obviously, because I'm going to smack down like a freaking nuclear missile. But I'll consider that a successful mission. So I'm going to end flight, and that's it.